Assalamualaikum warahmatullahi wabarakatuh. Kesempatan kali ini kita akan melihat webinar ya dari CSI-nya. Nah, ini tentang application of Auto Lateral Wind Loading di ETABS. Ini sudah saya terjemahin ya, webinarnya. Jadi kita tonton bareng-bareng ya, untuk menambah sedikit pengetahuan untuk aplikasi ETABS ini. Oke ya, lanjut aja. Ini totalnya ada 40 menit, jadi nanti kita potong-potong per 10 menit ya. Yes.
Everyone, we'll get started here in a couple minutes, but just a few administrative items before we get started. Due to the large number of attendees, we will be muting everyone's microphone during the session. You can type questions in the questions pane located in the control panel. I will answer some questions at the end of the session, but also feel free to send us comments about the webinar or additional questions to webinars@csimerica.com. Also, all webinars will be recorded and posted on our website. Okay, so let's get started. In this example, I'll be applying wind loads in two different ways. First, based upon exposure from extents of diaphragms, and then I'll be manually applying wind pressure coefficients to the walls themselves. So first, we'll talk about defining diaphragms, assigning them to the structure. Then we'll spend some time defining wind load patterns and going through each of the individual items associated with that.
Pertama dia mau bikin diafragma dulu nih, dia ngejelasin diafragma itu yang ada yang kaku, ada yang semi kaku ya, semi rigid dan semi rigid ya.
Run an analysis, we'll view the loads on the structure, we'll take a look at some response plots, view a summary report, and then we'll draw some auto cladding and then apply wind pressure coefficients to each one of those walls. Okay. So under the Define menu, we'll go to Diaphragms. And we have two different options here, rigid and semi-rigid. So for a rigid diaphragm, you have infinite in-plane stiffness and it doesn't exhibit any membrane deformation. And for semi-rigid, it simulates actual in-plane stiffness properties and behavior. So for the first example, let's use a rigid diaphragm. You'll notice that once I apply a semi-rigid diaphragm to the structure as well, the loads get distributed differently. And we'll take a look at that load distribution after analysis. So once this rigid and semi-rigid diaphragm have been defined, we need to assign them to the structure. To do so, we can go to the Select menu, and we're going to select all the floor elements. So if we go to Select Object Type.
Nah, dia ini mau objek dulu ya, plat lantainya. Jadi ini kita di plot dulu tadi di select ya, select terus object, dia milihnya nanti floor ini, lantainya ya.
And I'm going to select floors. Click the select button, and you'll notice here in the bottom left-hand portion of the screen, 19 shells have been selected. It's kind of a bookkeeping system, so it shows you exactly where the rigid diaphragms are going to be assigned to these 19 floor objects. So then we can go to Assign Shell Diaphragms. And we'll select rigid diaphragm and apply it to the structure. So you'll see here on the right side of the screen, this kind of spider web image represents the diaphragm which has been assigned to the floor element. And if I step down to each one of these floors, you can see that a rigid diaphragm has been assigned to each one of them. That's the base, and now we're going back up to the top. So you can see all of the diaphragms have been assigned correctly. Okay, so next, let's go and define a wind load pattern. Now, diaphragms are necessary for load applications to the wind loads themselves. So if we go to define load patterns, we can define a wind load. It is important to select the correct type when it comes to assigning a wind load, because ETABS will automatically generate load combinations for you and will associate the correct scale factor based upon the type of load which you have defined. So under auto lateral load, you can see these are all the different codes which have been included in ETABS. Many international codes, as you can see. For today's presentation, we'll be discussing the ASCE 716 code. Okay, for this first example, we'll be discussing exposure from extents of diaphragms, and we'll talk about the exposure from shell objects in the next example. So first, we need to define the wind pressure coefficients, windward and leeward. Windward coefficients are used in calculating wind pressures on the windward side of the diaphragm, the side.
Dia ngejelasin yang ini sekarang. Ada windward sama leeward untuk tekanan anginnya ya.
Exposed to the wind, and leeward side just the opposite. So we'll leave all the default coefficients 0.8 for windward and 0.4 for leeward in this example. Wind direction and exposure width. Let's take a look at this table. Okay, so we stepped through each one of the floors, showing you the rigid diaphragm had been assigned to each one of them. So ETABS understands and calculates the width and depth for each one of those diaphragms. Here are the X and Y coordinates for the center of mass for each one of the floors. Now you can see the exposure set width is auto-calculated based upon the location of the diaphragms in ETABS that we have assigned. But you can also define an exposure set that can be user-defined. So you can click on each one of these cells here and make changes.
Nah, ini bisa dihitung otomatis sama ini manual sendiri ya.
To them manually if you like as well. And there's a direction angle up here. So 0 degrees will be wind load applied in the X direction. We can also define another wind load pattern with different degrees, perhaps 90 degrees, which would be wind loads applied in the Y direction. So for this example, we'll keep the degrees at 0, wind load application in the X direction. Okay, next, let's take a look at the case ASCE 716. Now, the program combines loads for each one of the 4 wind load patterns. So if I select Create All Sets, ETABS will automatically generate all 12 load patterns for you based upon the different angles and E1, E2 ratios. Let's take a look at this in depth. So these are the different load patterns which will be automatically defined. PX and PY would be the resultant wind force in both the X and Y direction. And the E1 and E2 eccentricities for loads in the direction applied of the wind is input by the user. So you can see here, lateral force as well as torsional moment will be automatically applied to the structure. Here's another image I'd like to talk about. You can see that case 1 and case 2, full design wind pressure acting on the projected area perpendicular to each principal axis of the structure will be considered. Case 1 and 2 are shown here graphically. 3 and 4 will be defined just like case 1 and 2, but considered to act simultaneously at 75% of the specified value. So in ETABS, you have the opportunity to select each one of these load patterns and have them defined, or you could just select one, and ETABS you could define them manually as well. So you have a few different options to work with when defining the wind exposure parameters. Okay, also wind coefficients.
Jadi acuannya yang tadi ya, yang laporan dia itu tadi ke sini nanti ya diisi.
Can be defined, wind speed, exposure type, gust factor.
Nah, kalau tipe-tipe ini biasanya ini yang udah padat ya, kayak di kota. Terus yang C itu daerah kayak misalnya itu sawah itu ya, luas yang bangunannya jarang. Terus kalau D itu di pinggir laut biasanya ini dipakai. Terus nah speed ini juga nanti biasanya kita rubah. Kalau speed ini ya, speed kayak di C itu kalau nggak salah 110 dia, 110 ini dirubah juga. Nah, untuk D nya juga nanti dirubah ya. Kalau di D, kalau daerah pinggir laut kan anginnya juga lebih besar.
All these can be manually updated here in this form. Now for exposure height, top and bottom story height specify the elevation range over which the structure is exposed to wind. So I have it predefined where the penthouse roof, the top story, and the base, the bottom story, the full structure will be exposed to wind. Let's take a look at another graphic. Okay, see figure 3.1 here. Now this, I'm just pulling some of these figures from our lateral loads manual. Gives a good representation of how loads are distributed to the diaphragm using the extents of diaphragm method.
Nah, ini nanti kita
So here we see a building elevation on the left-hand side,
ini soalnya per 10
exposure width for the second level diaphragm as well as the roof level diaphragm. This is a good representation of our model, which does have a penthouse level.
Ada 40 menit. Oke.
You can see the
Assalamualaikum warahmatullahi wabarakatuh.